3-2, we're back at it here. So we're going to calculate or use a graph to help us calculate or determine the equation of some of these graphs that we have here. Okay. So let's say we have this this sine graph here, right? It's a typical sine graph. I could look at the sine graph and say that the period, if I measure the period out correctly here, is going to be this piece right here. So that's going to be my period, 0 to 360. So my period is going to be 360 degrees. Or if I'm in radian, because this is in degree mode right now, if I'm in radian, this would be 2 pi, depending which mode we happen to be in, if we're in radian mode or not. Most time when dealing with graphs, we're going to be dealing in radian modes. When you do regression, we want to be in radian mode for regressions as well. The 360 is more useful for communication purposes. Now, to determine the b value, now this down here says determine the period if I know the b value, but the key is how do I get the b value from the period? So I measure the period to be 360. So the b value is going to be whatever the original period was, the original period divided by the current period of the graph. So that's what the b value is always going to be. The top number is the original period, and this is always, the top is always going to be 360. Because the sine graph, that's what this sine graph we drew here, is always going to be a period of 360. And the period of the new graph is the new period, right? So the b value for this is pretty easy. It's 360 divided by 360. It's 1. So if I graph sine x, I should get this graph. It hasn't changed. Sine 1x. So if I go back to my Desmos here, let me just get rid of all this stuff up here. And let me just graph sine 1x, right? It's the exact same graph. I shall just change the color so you can see that. Put red, purple. Yeah, let's put purple there. Okay. So these two graphs are the exact same graphs, right? The b value is 1. It doesn't change the period, so that's going to stay the same. Let's go back here. So if the b value changes, that will change the period. So if I go over here and I say, okay, what if my b value is 2? If my b value is 2, my period for my graph is going to be 360 divided by 2, which would be about 180 degrees. Okay, so if I go to Desmos in here, let's go to Desmos and check that out. Let's put a 2 in here. Let's zoom this a little bit more. There's one graph right there up to 360. If I put a 2 in there instead, my period is now only 180. So yeah, so it holds true. Looks pretty good. I can verify that for some more of them. If I put a b value of 3, it should be a third of that. So it'd be about 120, and I can do that too, but I'm not really going to bother. Right? There's my example for this one. So what we're going to do, let's start with my writing. It seems like it's getting worse every day. Okay. We're going to look at some of these now. Okay. So we're going to determine the amplitude of some of these graphs. We're going to determine some of the periods of these graphs. What we were to discuss before is my a value, my amplitude. I'm going to go back up to the top here. Maybe you should go back to the top as well. My a value is my amplitude. My midline is my d value. And if I have the graph, I calculate that by going min minus max, like we did before, divided by 2, or max plus min divided by 2. But those are those two values. So my a, my b, and my d. You know, so kind of ignoring the c for now. The c is the trickier one. We'll worry about that in a bit. Maybe the next video. Okay. So here, let's go through this. So the a value in the form a sine bx plus c plus d. A value is the one that's in the front. That's my amplitude. So my amplitude for this one's 5, this one's 3. I know it says -3 there in the front, but remember the amplitude is always a positive number. The negative just flips the graph over, and we're not too concerned about that. And then my amplitude for this one's 0.95. Okay. My period, remember the period is related to this b value, whatever's in front of the x. That's in front of the x. Multiplying with the x, that's my b value. It's related to B, it's not B, by going 360, and now maybe we want all the periods to be in radians in this case. So we're going to use the other one. We're going to use a 2 pi rather than 360 in the equation. So my period is going to be 2 pi divided by b, rather than saying 360, because usually it would be 360 divided by b. But we can change that to 2 pi divided by, because 360 and 2 pi are the same thing. Yeah. Okay. So my period, do we want this to be exact answers? Round the value of the period to the nearest tenth where necessary. So my period for this one is going to be 2 pi divided by 1. I'm going to leave this as 2 pi, but if you want to put that in decimals, you can. You go 2 times pi, you get 2.3, or 6.3, sorry. 6.3. Okay. This one here, you're going to do the same thing. We're going to go 2 pi divided by 12.2. 2 pi divided by 12.2. And I get a period of 0.5. I don't know what I was saying there. Okay. So yeah, you notice that the B value got larger. So my period kind of got squished in. It means I can put 12.2 graphs in the same amount of time. This one here is going to be 2 pi divided by 10. I want to put this as an exact value. This would be pi over 5. But let me just put the math there. This ends up being 0.6 to the 10. Seems very lackluster. Just put down 2 numbers there. Cool. Okay, I'm going to pause the video. I want you to try out this next one. Okay, so let me try these out. So the period for this one is going to be 2 pi over 6. So you're going to just reduce that down to the nearest tenth, I believe, again. So let's just punch in my calculator. And you get 1.0. Doesn't quite round up. My amplitude is going to be 1 because the number in front is 1. My amplitude for this is 0.3. My amplitude for this is 8. This one here is going to be 2 pi over 2, which is pi. That would be 3.1 in decimals. And this is going to be 2 pi over 9.25. 2 pi divided by 9.25 is 0.6. Oh, I was going to say 67, but I'm going to have to round it. 7. Cool. So what we could do now is we can actually reverse the operation. We can actually take an amplitude and a period and change it into an equation. Now, to find out the A value of the equation, that's easy enough. That's my A value. So these two numbers are my A value. My B value in my equation is going to be the opposite of this equation. So period is 360 over B, or 2 pi over B, depending on which mode we're in. But B could either be 360 divided by the period, or it could be 2 pi divided by the period, depending on which mode we're in, whichever measurement we have. So in this first case, we have it in degrees. So we're just going to use the 361 divided by 180, and I'm going to get a B value of 2. Okay, so the equation here is going to be y is equal to A, which is going to be 6, sine bx. So b times x, like that. Sometimes you don't write it with the brackets. You might see it written like that, but that just implies that there are brackets there. This one here is going to be the same. I'm going to go 3.5 for my A value because that's my amplitude. This one here, to find my B, I'm going to have to use the 2 pi version of this. Well, that's nice. The pi's cancel out here, but if you just type them in your calculator, 2 pi divided by 10 pi, I should get 0.2. 0.2. You can also go math, enter. You get 1/5 Either one of those is fine for this. So I can have 0.2x. I can write this as 1/5 x as well, like that. Or x over 5, or however you want to write it. Maybe I'll write it a different way. So these are all proper ways to write them. I don't care which way you write them. They all mean the same thing. Your turn. So you have two more here. I want you to try them out, create some equations for these. I'll see you in a bit. Okay, so hopefully you tried this out. So remember your amplitude is A. Your B value is going to be your original period, which is always going to be 360. I keep on saying original period because if you go into future math classes and then we talk about tan graphs, the original period of a tan graph is 180 degrees. So that changes quite a little bit. But this one here is going to be the original period divided by the new period. So whatever 360 divided by 45 is, then we get 8. So my B value is 8. I might as well just do this one right over here first. Because we're in radians here, we're going to have to use 2 pi, that's my original period, divided by pi over 3. This one's a bit trickier to do. Remember, you could do this algebraically. You flip it over, you multiply by the reciprocal, because you're dividing by a fraction. I get 6. All else fails, just plug it in your calculator. Just go 2 pi divided by pi over 3. You get 6. I put the parentheses around that pi over 3, so maybe you should too. So my equations. So my A value, sine 8x. There we go. And then the equation for this one is going to be 15 sine 6x. There you go. Cool. We're pretty good. And we always deal with sine graphs. We're not dealing with cos graphs or anything like that. The next graph or next video, we're going to look at equations and say, or look at graphs and determine equations from the graphs. So it just adds a little bit of extra steps to it to remember what the A's and the B's and there's no C or D's in these ones. But that'll be the next video. Okay, I'll see you then.